Situated in Lincolnshire, Royal Air Force Binbrook is the home of the last operational Lightning Squadron. The passing of the Lightning represents the end of an era.
I was the first tourist on the Lightning. I had had a look at the Lightning at Valley. One was diverted in for bad weather on one occasion, and I took the opportunity to go around and have a look at this aeroplane, and having sat in it, having walked around it, I was captivated, and for me there was no other aeroplane. So I made a complete nuisance of myself through the training system until I was posted to Lightnings, and I've never wanted to fly anything else really. I have to accept that now the Lightning is becoming dated, and it would be nice to go and fly something like an F-16, but these are dreams, I'm afraid. It's busy, the workload's very high. The ergonomics of the cockpit for the age of the aeroplane are actually remarkably good. The instruments are clear, most things fall to hand quite readily, and it's a big, powerful aeroplane. And I think this is the thing you notice, particularly for a first tourist going through, or even more so nowadays, where young lads fly the Jet Provost, they do their advanced training on the Hawk, they do their weapons conversion on the Hawk, and then they go straight onto the Lightning. It's a big, powerful aeroplane. It's like getting out of a mini metro and getting into a Formula One racing car, that sort of jump. When I went through, we went through on the Jet Provost, the Gnat, and the Hunter, which is a much more graduated transition to a big aeroplane like the Lightning. But the workload in the cockpit is high, single seat. You're interpreting the radar entirely by yourself, unlike modern aeroplanes which have a fully automated system. The Lightning, you get a raw blip and you've got to process that. There are very few automatics in the aeroplane, and the things we now do with the aircraft mean that the workload is extremely high. When I first flew the aeroplane, we did very little overland work. We did very little ECM training. We did very little combat. But now we explore the aircraft. We wring every possible ounce of ability out of the thing, which means that the workload is even higher. And I'm quite convinced that if a young pilot now comes onto the Lightning and succeeds, there is nothing else which the Air Force owns which can cause him any problem whatsoever.
You will never meet anybody who can read a book and know it for the rest of his life. I mean, everybody has to refresh and revise, and that really is the art of being a fighter pilot. That is why we can do such short briefings, because we don't have to labour points. We can just go in there and say, today we're doing this, and it's standard operating procedure, something we call SOP, and we just get on and do it. And that is why people enjoy doing the job. A sortie could be a practice scramble, which you'll do, where when you're told to vector for a target, you're not actually told what it is, what it's doing, or anything. You're just told to go. Once you're airborne and sorted the aircraft out, heading towards the target, then you might get an idea of what you're up against, but it could be anything. It could be a defector in wartime, even in peacetime, obviously. It could be somebody who's in trouble, a civilian who's lost, radio's gone down, running out of fuel, somebody with an emergency, another military type or civilian type. You never know. It could be somebody supersonic. You have to have everything at your fingertips to act accordingly and do a good interception. Bearing in mind, of course, we've only got 50 minutes of fuel, and if we don't get it right the first time, you just can't go around for another one. It's either miss and come home or get the job done. That's basically a day. That is not including, of course, all our external commitments when we fight other aircraft doing combat or a fill. That's more complex. And we, as fighters, are always on either a cockpit readiness state or a in the crew room type state. I'm not talking about crew room where I'm sitting now. We have one literally 10 meters from the aircraft. There, you have to be airborne within 10 minutes, day or night. So we all know what the feeling is like when you wake up in the middle of the night. The phone rings or the baby cries, whatever. You jump out of bed, you stagger, nearly fall over, trying to get your wits together. Well, we've actually got to get all our flying kit on, strap in, start up, take off in whatever weather conditions, in pitch dark, within 10 minutes. And 10 minutes later, you can be plugging into a tanker. Tankers, you see, because they take long to start, with more crew, they're on sort of different readiness states, but they're brought up as time goes on. So if they were on 3 hours, they'd be told to come up to 1 hour, so they'd all come in and get ready. And being tankers, of course, the 1 hour gives them time to have a big hearty meal, because they must have that before they fly. And then, of course, they will get scrambled if there's any chance of gyro being launched. And normally they'll be there to meet you, so they'll get launched, and we'll get launched, meet up, go together, and they'll top us up for a maximum of 12 hours. Having said that, if something pops up unexpected, we will just launch that tanker and go and have a look. So they've got the one who's airborne, the tanker then can get scrambled, and then you've also got Q2 who can get airborne to relieve number 1, and a third aircraft would be up to state anyway. So we always defend our airspace all year round, 24 hours a day really.
The Lightning will be remembered as the only supersonic single-seat fighter developed by Britain. In August 1954, Rolly Beaumont began test flying the experimental prototype designated the P-1.
On Flight 3, we had very successful handling experience on Flights 1 and 2, and we'd come into 1 or 2 minor problems that needed looking at, but nothing to stop us going ahead. And on Flight 3, it was decided to take the then cleared flutter speed of 450 knots up to the tropopause and see how it behaved up there. On the previous flight, we'd been to 0.98 Mach number at 30,000 feet, and the airplane had seemed to stop there as if it had come up against a fairly formidable drag rise. But on this particular flight, we accelerated at about 32,000 feet to 0.97, and then held full throttle in level flight, and it was a clear day going down the Solent towards Selsey Bill. I remember wondering whether we were going to be stuck against this drag rise, because the Mach meter was only showing 9.8 for what seemed to be quite a long time, and all of a sudden, while I was thinking about this, it gave a bit of a shake and swung up to 1.05 without a tremor, without any vibration, no trim change, nothing at all. It just a movement on the Mach meter, and there we were, supersonic in level flight for the first time in a British airplane. Just to make sure that there was no doubt about this, I throttled back somewhere between Selsey and Brighton, turned left, a very clear day, I could see the whole of the south of England pretty well, throttled right back, we were getting fairly well down on fuel, set up a heading back for Boscombe, called Boscombe that I was returning, and then when over Winchester, still at about 30,000 feet, I thought, well, we'll prove once and for all whether this Mach meter is accurate or not. And I pointed the P1 down to the centre of Boscombe Down, which you could see from miles away with its long white runway. Eased the throttle forward at about 29,000 feet, just slipped through Mach 1 on the Mach meter, and by the time I got down there, nobody was any doubt at all that the P1 had gone supersonic. In 1957, we had the P1B fighter variant with 2 Rolls-Royce RA-24 engines with reheat, and the revised cockpit necessary for a fighter. The pilot sitting position had been raised, and the windscreen raised, and the canopy raised above the rear fuselage line to provide a degree of rear vision to the left of right. It wasn't perfect fighter vision. As the test pilot responsible, I tried to get the designers to produce a one-piece canopy with 360 degree or with 180 degree rear vision all round. But they'd said that in the interest of safety, with an airplane which was potentially going to get out to Mach 2, twice the speed of sound, that they would need a mixed construction canopy, because they said an all-one plexiglass canopy would possibly suffer thermal distortion at the temperatures associated with twice the speed of sound when we got there. Well, this was possibly over caution, but anyway, we did have a slightly improved vision for the fighter pilot in the P1B, the Lightning. Did the first flight of the P1B in May 1957, and this was a very, very remarkable experience, because it was essentially a P1 with all the excellent qualities of control of the hydraulic power control system of the P1, but with very substantially more power. We had two RA24 engines with reheat, each of which gave 15,000 pounds thrust at sea level. At first flight, the P1B prototype XA847 weighed 28,500 pounds. So we had a better than 1-to-1 thrust-weight ratio on that aeroplane, and it was the first aeroplane of its category in the world that was in fact able to stand on its own reheat thrust.
The English Electric Lightning is an all-weather day and night aircraft, designed primarily for high-level supersonic interception. It has a fully integrated weapon system. The Lightning is a versatile aircraft. It can be used for a wide range of other operations, including high and low-level interception, ground attack, and photo reconnaissance. It is in service with the Royal Air Force.
The Lightning is still the keystone of RAF defense against the high-speed, high-flying bomber. Takeoff is accomplished in less than 1,000 yards, and its operational ceiling can be reached in about 2 minutes. Despite its Mach 2 performance, the Lightning is one of the most docile of the military jets to handle. It's been subjected to an extensive series of spinning trials and recovers from a 2-turn spin in less than 5 seconds.
Spinning to the right, quite oscillatory, and at 1 turn, 2 turns, rudder, stick going forward, coupling.
Being air defence pilots, most of the things are taught very well throughout training, which is a year and a half here on the Lightning, and is retained in the person's head, basically, all the procedures and what have you. So he does not have to just plan maps, etc. So therefore we can start a bit later than the normal flying squadron, and that would be for something like 7:45 Met brief. So pilot would come in, go to Met brief at 7:45, usually get back to the squadron about 7:55, quick cup of coffee, change it to flying kit. Obviously the thing you'd actually do first of all is when you actually walk out to an aircraft is your walk round. We methodically have a sort of left to right system where you'd start by the ladder. Most people would just deposit their helmet there and have a look at the missile, the covers on the missile. You'd go around, you'd check there was nothing in the intake, nothing was left there, that the radar bullet itself was in order. The pitot probe at the front, you want to check that it's not blocked, and the standby one above. You'd go around, just check that the nose wheel covers are loose enough and not stiff, so the nose wheel will go in. And generally go around the aircraft, just checking that there's no drips from unusual places. The Lightning always drips a lot anyway. But you'd be looking that there would be no hydraulic fluid, for instance, coming out, either down the oleos or around the actual system. And the guy's just looking for panels, making sure there's nothing loose, nothing hanging off, all the pressures are right on the certain skin gauges that are around there, that the wheels are in good order, there's not a big crack developed where you could get a tyre burst. With the sort of high tyre pressure we have, obviously we're quite interested in the condition of them. And you just generally go around checking everything's good, that all the locks and flags are away. So you do all that, and When you are happy with it, you then would climb up the ladder, and before getting in, check the ejector seat. And that is your last hope when you're flying. So guys are pretty particular about that. So you check the seat completely, and then you making sure also that the pins are safe. You'd sit down and you'd want to get some of the systems started before you strap in, because by the time you're strapped in, you'll have a few things running for you. And normally a lot of items take about 2 minutes to warm up. So you would check, first of all, that the undercarriage lever was down and was not in the up and retractable position. You don't know, you've just walked out to an aircraft, anybody could have gone up there and messed around with the cockpit before you put power on. Once you've got the power on and you've checked the power works and your own aircraft internal power works, i.e. the battery, you would then start switching a few things on, like the radar, your main instrument panels, radio, and other associated equipment that takes time to warm up. Once that's going, you then strap in. You have a ground crew member just to help you. Normally a guy can strap in fairly fast and comfortably within a minute. Once you're strapped in, of course, you take your pins out and stow them, and then it's a case of just going left to right around the cockpit. We all have procedures, and you learn procedures, and once you've actually been doing it for a while, anybody who's got anything over 50 hours on the aircraft, it's quite natural to do. You go around switching things on, checking things like oxygen, fuel, you name it, you check it. There's not a dial there that isn't looked at. The main interesting thing about it is probably something to do with human nature, is as you're actually sitting in a cockpit, your eye just immediately picks up a switch or a toggle or something which is amiss or wrong. Even without being part of your check, you haven't actually even started left to right. For instance, that's just left side of the cockpit. Your eye will pick it up. And it's just one of those things, you can jump in and immediately go to it. But that is normally the thing you do. You check everything, and when you're ready to start, you just give the signal to the ground crew. And again, there's a few checks just to make sure everything's working in order before you start the aircraft. And it's a matter of starting one engine, checking out the systems from that engine, because most things are duplicated, and then start the second engine, and again test the systems out. Once you've got both engines running, the canopy's down and you're off, and then it's just a matter of taxiing to the takeoff point, and whilst you are taxiing, to just go through all pre-takeoff checks. And it's no different from being on a civil airliner to a helicopter or a fast jet. The only difference, of course, is you're on your own and they're in your head. You might well have seen people who, when you have films of airliners, one will read out a check and somebody will come back with if it's been done or not. But we have to know everything off by heart, word perfect, in our head. And I'd actually say that out of two sets of checks, i.e. the pre-takeoff and the pre-landing checks, they're the only ones that people do make sure they know word perfect without actually going in the wrong order. They do know them word perfect, and they do it word perfect. For that reason, you will take off with two engines in good order and with the right bits of the airplane down, and you're not going to lose something like a canopy, and you're certainly not going to have to eject and worry or die because you have forgotten to take a pin out. And most pilots, in fact I'd say all pilots, because you know, sitting with people when they do their checks, the sort of things they do just before they take off is always check the caravan. That's a control who's on the side, just to make sure that he doesn't spot anything, that they've got full control movement, because the last thing you want to do is get airborne, pulling back on the stick and find that when it rolls you can't correct it, and then you just roll into the ground. So they'll do controls, they'll check the captions all out, so you've also got no problems. The canopy is locked, and that is important because at about 140 miles an hour, that's about the time when it will lift off. Just as you're raising the nose wheel, that is when it would go. So you check those. So captions, canopy, pins, those are the last things. But pilots generally throughout, they survive on drills and checks. And the nice thing about it is the more you do it, the more it becomes second nature.
Computers are good, nozzles are good, captions are long out, flare size reading. Airborne. Lights out. I'm on airborne 3.
If we take the average bread and butter sortie, this is not one of the more exotic profiles, but a straightforward sortie will be, say, subsonic intercept practice over the North Sea. We will conduct this with 2 aeroplanes, 2 Lightnings. We'll take off from Binbrook, transit out through the normal air traffic radar until we talk to Bulmer or Stexton Wold, which are 2 military radar sites on the east coast. They will then control us and split the pair up. One aeroplane then will run as target and the other one runs as fighter. And we operate right through a profile, detecting the target, shooting it down or identing it as the case may be. And then we swap over and the first chap becomes fighter and the other guy becomes target. And we will run that through, say, half a dozen intercepts until the fuel is getting low. The fuel in a Lightning has always been a problem, but on a subsonic sortie, we can expect about an hour's duration. On a low-level sortie, this could be about 45 minutes. And on one of the more exotic sorties, like combat or low-level affiliation, then it can actually be as low as 30 minutes. This does mean that the pilot's fuel awareness has to be exceptional. It's a very unforgiving aeroplane if you do run short of fuel. It's a big, powerful aeroplane, it's a very thirsty aeroplane, and the fuel does go down very quickly. I would think most Lightning pilots of my vintage can recall an occasion or two when it's been a bit less than it should have been.
30 Bulmer, have you identified? Call Bulmer, stud 12.
Stud 12. Bulmer 30 on handoff.
30 Bulmer, you're loud and clear, how many?
Loud and clear 30.
Roger, you're just 4 miles due east of Alpha. Maintain your present heading and level.
Roger.
Come right, heading 060.
060. Steady.
30 maintain, advise, ready for trade.
30 is ready.
Roger 30 on heading 060, target 20 left, range 25, no known heading and height.
Roger. Contact slightly above.
Roger.
Coming back into Binbrook, then we normally land with 800 pounds a side. That's a meaningless figure to someone not in the know, but that gives us enough fuel to land comfortably. If we have a problem with the undercarriage or someone crashes on the runway immediately ahead of us, it gives us enough fuel to go to an emergency diversion, which is normally within about 20 miles. If the weather is poor or there are other considerations, then we may come back with a higher fuel reserve. Coming back into Binbrook, our normal way to get back in is a visual approach. And if the weather is good enough, we quite simply find Grimsby and continue in, find the airfield and break into the circuit. But Binbrook's fairly notorious for its weather factor. Quite often in the winter time the weather is quite poor, and under those conditions then we will have to use either the instrument landing system or an air traffic control, ground control approach.
Is the pair online?
Yeah.
Affirmative, it's now on the site.
Yeah, Roger, can you get me in onto that beam?
Yeah, let's try now.
Roger, still steering 240.
Roger. Yeah.
Unfortunately, my TACAN's dumped, so I can't give you a radio bearing.
Provided you keep your wits about you, provided you keep thinking ahead, and provided you work well with air traffic controllers, there are no problems. But it is easy to be caught out, and again it comes into the whole problem of flying the aeroplane with a high workload and the necessity for a very high situational awareness.
India, Bravo and Oscar for myself and the boss, T5's to be allocated by the engineers, okay? So the call sign is Bravo for, Bravo's your aircraft, sir. I will take Oscar, that's the one with the Dicky MRG around me, so I thought you'd better have it 200 feet. I will be listening out as you go through the box with Aberport to get airborne in suitable time. Proper technique. Is it possible to let us do as we did this morning, which is stay at about 350 knots until -2 and then accelerate to datum? Spin run through again. Obviously, you didn't know if it misfired this morning, but if you did, fire street misfire drill, safe direction, switch is safe, tell everybody about it, land a sap, safe heading when you get down, don't rush back because you need 30 minutes on.
Okay, well, I've spoken about the day-to-day intercepts when we practice shooting down other aeroplanes, and we take the intercept to the point where we press the trigger and a little light comes on in the cockpit which will tell us whether or not the missile would have gone. Clearly, we have to be experienced in firing the missiles as well, so the next step is to take the squadron to Valley in North Wales, where we carry out a missile firing practice camp. We use as a target a small radio-controlled aeroplane known as a Jindovic, which tows behind it a magnesium flare, and we are controlled very closely around a pattern by the radar unit at Aberporth. And they take us around various checkpoints on the profile. At each checkpoint we have to ensure that various checks are done within the aeroplane, that the missile system has armed up and so on. And by the time we're at about 2 minutes to the firing, then we are picking up the target on our own radar. Once we're down to about a minute to go, we can generally see it visually, and then very close to the actual firing point, the flare is lit by remote control from Aberporth. Once the flare is lit, then we are clear to continue with the attack, and we can, the infrared seeker head on the missile will see the target. We receive an indication that the missile can see the target, and then we can fire. And it's all over very quickly after that. The missile leaves the aircraft and home straight on the target normally. one of our secondary roles, other than air defence of the United Kingdom, is overseas reinforcement. And we practice this in conjunction with our armament practice camp, which we do in Cyprus every year. The entire squadron deploys from Binbrook to Akrotiri in Cyprus by means of air-to-air refuelling, normally with VC-10K tankers or occasionally still with Victor. Underway. Now, the big advantage of going to Cyprus is that the firing range is some 20 miles south of the base, whereas if we do the same exercise in UK, we have to transit nearly 100 miles to the operating area. Also, the weather is consistently better, and the whole program becomes much easier. The aircraft are armed on the ramp at Akrotiri, and as they taxi out and leave the ramp, then the final safety device is removed and the aircraft can then proceed to the runway. Similarly, on taxiing back in, the safety device is refitted within the wing route by the ground crew before the aircraft taxis back in beside the other aeroplanes. way we run the APC is that a banner is towed behind a Canberra aeroplane, a safe distance, about 300 yards, and the aircraft go and fire on this banner. However, before clearing a pilot to fire live, he must prove that he is safe and consistent, and this is done by means of cine sorties. And each pilot will fly up to 6 cine sorties where the film is brought back and assessed for angle off and range and tracking before he's cleared to fire live on the banner. Once he goes live, we fire, say, 4 pilots on the same banner, and we get around the problem of scoring by each pilot firing different coloured bullets. The banner is then towed back to Akrotiri, dropped on the airfield, picked up by a Land Rover, and we can actually count the holes in the banner. It's very hard evidence. There is very little negotiation. A colour is a colour and a hole is a hole. Once the pilot has reached a certain level of scoring, he is then deemed to be ACE qualified. That's ACE as in Allied Command Europe, not ACE as in the usual slang term. Once he is ACE qualified, then each pilot goes on to a more difficult style of shooting called limited operational shoot and then an operational shoot. And once the pilot has done that, then his part of the APC is complete. It's an extremely demanding exercise because of the gun sighting system in the aeroplane. It's not very advanced. We get no automatic range readouts. Again, it's all down to pilot judgment and basically pilot skill. But it's a very rewarding exercise, and it's also tremendous fun and very enjoyable.
When Binbrook was fully operational, we had 2 squadrons, that's numbers 5 and 11, and also Lightning training flight. And these 3 organisations handled the aircraft from day to day and did the engineering for routine unserviceabilities from day to day, and obviously kept as many aircraft as they could at front line ready to go every day. Now to back them up, there was Mechanical Engineering Air Squadron that looked after the scheduled servicing, the routine servicing on the aircraft every so many flying hours, and also looked after the airframe, mechanical components and the engines. And there was also Electrical Engineering Squadron who looked after the avionics components when they were removed from the aircraft. Now, as 5 Squadron and Lightning Training Flight have both disbanded, we're the only operational squadron left, so of course the second line element has contracted along a similar scale. So now we have Aircraft and Electrical Engineering Squadron who do essentially the same job, but just with a smaller number of aircraft involved, so the task is correspondingly reduced.
All control surfaces are power operated by hydraulic systems completely separate from the normal aircraft services. The twin-engine layout of the Lightning permits full duplication of the primary power source, each engine driving a separate pump with an independent oil supply and a separate circuit. The 2 circuits are also routed apart to avoid simultaneous damage. The flying controls are irreversible and provided with cue and spring feel. The normal aircraft services systems are used to operate the flaps, undercarriage, air brakes, and a number of other facilities.
The Lightning uses 2 Avon 302, Rolls-Royce Avon 302 engines. They're old, but they're reliable basically because they're simple. They're very robust. They can keep going with a lot of damage. Quite often the pilots will come back from a sortie, declare the aircraft fully serviceable, but we then subsequently check down the intake and find that there's a lot of damage to the engine that the pilot didn't know about. So normally they're very reliable. But one problem we do have with this aircraft in that it tends to pick up a lot of debris from the ground, and also jet blasts from aircraft taxiing by. And the design of the aircraft with the engine going right through the middle of the fuselage structure with lots of systems packed around it, ingestion of loose articles can cause a problem, and of course if it goes through the engine it'll wreck it. Fire protection systems are limited to the numbers 1 and 2 engine bays in which there are fire extinguishers, and there's a fire detection system in there, and sets up a warning for the pilot, and he will fire the extinguishers in numbers 1 or 2 engine bays. Now, down the back end of the airplane in the reheat bays, there's fire detection systems, but no protection. So if there is a fire, you've got to shut off the reheat and hope it goes out. If it doesn't, then it's not your day. The layout down the back end, of course, one reheat pipe on top of the other, it's somewhat unorthodox, and to a great extent it does cause us many problems, in that if you get a leak from the number 2 system anywhere, that's all going to pour straight on top of the number 1 system. Hot jet pipes plus fuel equals fire, and many aircraft have been lost due to fires. But since the advent of the fire integrity procedures, whereby every time an engine or a jet pipe is removed from the aircraft, a thorough inspection of every fuel pipe and every hydraulic pipe is carried out, even to the extent of, for some fuel pipes, x-raying the couplings to make sure that the seals within those couplings are properly bedded in. And since the fire integrity procedures have been introduced, the numbers lost due to fires have significantly reduced. Well, the basic difference between the Lightning, the reheat on the Lightning and any other aircraft is the distance between the engine and the reheat. Most conventional aircraft, the reheat system is mounted immediately behind the engine, but in the Lightning, certainly the number 1 engine is only halfway down the aircraft and the reheat is right at the back. So to ignite the reheat system, a great squirt of fuel is sent back from the engine right the way down the interpipe to ignite the reheat system at the back end. So that certainly makes it unique in that regard. The engine starting system on this aircraft is unique. It uses its own fuel, AVPIN, isopropyl nitrate, to use its chemical definition. It's a mono fuel, basically, so it contains its own oxygen. It'll burn without oxygen. Very combustible, very dangerous, so you've got to be very careful when you handle it. The starting system is quite unreliable, and to get through a day's flying of, say, 30 flights without an aircraft failing to start would be most unusual. There are various checks you can carry out to determine what has gone wrong in the starting sequence, but before you did that, you'd give it another try. Then maybe try and get the air valve to open, for instance. If you get that open using some compressed air or some boiling water trickled down through one of the air pipes, try again, and maybe if you're lucky it'll start. But if not, you're then into an open investigation, and you've got to pull the system to pieces and try and find out what's wrong. If you do try and start too many times without a thorough investigation, the starting system has been known to explode. So if you just keep pushing the button time and time again, hoping it will eventually start, there is a serious risk of an explosion of the starter system. And that's, of course, buried in the middle of the aeroplane, and if that blows up, then it could take the aeroplane with it. Lightning has a somewhat unusual electrical generation system in that the generators and alternators are not directly driven from the engine, but by a turbine which takes its air from the engine compressors and driven through a gearbox to drive the main generators. And there's another standby generator just in case the main one fails, but that again is driven by compressed air from the engines. There's a main AC alternator, a main DC generator, and a standby DC generator to power the aircraft systems. 28 volt DC and 200 volt AC. Conventional aircraft power supplies, basically. Now, apart from its actual layout with one engine on top of the other, the actual structure is absolutely conventional. It's just aluminium alloy ribs and stringers with a stress skin over the top. So there's nothing unconventional there at all. it's very basic. But it is very robust, and I dare say if the aircraft were designed or built now, it would be with a much lighter structure. Of course, when it was built in the initially in the 50s, knowledge of supersonic flight was fairly limited, and I think they made it stronger than they would with today's level of technology. Unnecessarily strong, I think. But of course they didn't really know that in those days. Talk to the pilots and the engineers who work with the aircraft from day to day, you'll get regret and relief will be the major feelings at the end of the day when the squadron disbands. I think more regret than relief with the aircrew, and I'd say the ground crew would be the other way around.
It's such a lovely aircraft to fly. It might be 30 years old, but it's like an old sports car. It's something you just don't want to put down. It's marvellous. It handles well, it flies well. Okay, the weapons and radar are out of date, but the actual aircraft is just a joy to fly.
How do your colleagues feel about finally seeing the Lightning phased out?
Very sad on the personal side. It's better for the Air Force to get new aircraft, but as far as we're concerned, it's a lovely aeroplane, and we just love to keep flying it. But having said that, the days we do use it on QRA, it does very well. It's not unusual to do 5 or 6 hour sorties up north of the Shetlands, intercept a Russian and come back, and that proves the aircraft can still do what it's meant to do.
Well, it's always had certain disadvantages compared to some of the more modern aircraft, in as much as it was designed and is a fairly short-range interceptor. The avionics is getting a bit old, and the weapons system's getting a bit old. In terms of sheer airframe and engine performance, though, it's still probably better than anything we've got. And certainly we do a fair bit of flying against Tornadoes, against Phantoms, and aircraft such as that against the Harriers. And we're more than content with that, and we certainly do better than holding our own against them.
One downwind, the wind 230, 15 knots. Come on. Okay, brakes in with it. Gear. Fuel we got.
Finals, gears down, contact 1 ahead.
17, clear land, 1 ahead landing.
Clear land, 17.
Try and make it smooth as possible.
One clear short.
1 affirmative.
Oh.
Someone pick it.